here we have a pretty typical linear function, identifying a linear function type of problem. And so as it says, does the set of ordered pairs represent a linear function? Explain your reasoning. Okay, so I've got these 4 ordered pairs, and I'm only going to use 3 of them, and that's because only 3 of them will fit on my graph. And the first thing I did with these was I put them into a table of inputs and outputs, x over y. And remember, the big thing here that we are looking for is our rate of change. Remember, our rate of change is our y over x, our slope, and it needs to be constant between these values. And the first thing I'm going to do is I'm going to look at my x values and see what the distance is between each x value. And the distance between each of my x values, as you can see in the table, is between 1 and 2 is 1, between 2 and 3 is 1. And when I say distance, I mean on the number line. How far apart are they? Okay, how about if I look at my y values? The distance between -3 and 2, that's 3. And the distance between 2 and 5, that's 3. All right, so I know that they are constant, that I've got a constant rate of change. So the slope between these points should be 3 to 1, right? Because the distance between these points, pardon me, between here and here is 3, and between here and here is 3, and between here and here, hopefully you can see this, is 1, and between here and here is 1. All right, and the next way I can tell, to be certain and to illustrate this, is by putting it on a graph. I put the points 1, -1, 2, 2, and 3, 5. And I'm claiming here that the rate of change, by the way, is 3 over 1. Right? Rise, run. So let's see if that's true, okay? I'm starting here at -1, 1, and I'm going up 1, 2, 3, and over 1. Hopefully, yeah, there we go. It's going to do it again. I'm going to go up 3, 1, 2, 3, and over 1. And yeah, clearly this slope is consistent. It's 3 over 1 in between the points. If drawing this line, right, I can see that I've got a slope of 3. All right, so yes, this is a function. I know it's a function because the rate of change to the slope is constant. And it's a linear function, of course, because it's creating the graph a straight line between those points. All right, and maybe we should just sketch the line so everyone can see it. Everyone thinks I'm losing it here. All right, and of course you should use a ruler even though I'm not. All right.